Hi everyone. In our last lesson, we created our struct for the exam smart contract, and in this lesson, we are going to define our thread local, and we will see how we can write this data to our stable memory. First, remember what we did in our last lesson. We had our struct as exam here, and under the exam, we defined two different traits. First one was for the functionality to serialize our data to bytes and deserialize from the bytes. And to do this, we also edit this deserialize macro here to our struct, and also we edit this candid type so that we can work with candid file here. And inside this trait, we had 2 bytes and from bytes. This one returned our structure. And also we had bounded storable, and this was for the limitation of our structure, and we said that it's going to be dynamic by saying it's fixed size false. And we also said that the max size will be 100 as we defined here. Now that we have our structure that can work with our stable memory, we are going to define this in a thread local. We are defining this in a thread local because we are actually utilizing multi-threading here, and with the thread local we will create thread specific variables. So this will be specific in the thread, and since ICP uses single thread, we will have no problem. And also in this trait, we are going to define our variables with a RefCell. So RefCell is actually a little trick that Rust offers to us. As you know, we cannot alter the immutable variables in Rust. But if we have a variable in a RefCell, then we can actually borrow this as a mutable or immutable. So our fixed thing will be the RefCell itself, and we will be able to manipulate the data inside it. Even we define it as immutable because we will be able to borrow it as mutable. Okay, I know I said a lot of things. Now let's see how we can do it. First, we will say thread local macro here, and inside this I will create a static memory manager. So this memory manager, as you can understand from the name, is going to manage our memory. But the question is that why we need our memory to be managed. Since we might want to use different structures and have different structures in our code that we want to save for the later state upgrades, we need this memory manager because we actually have one place, just one data that we can hold in this thread local. So what if I have one exam here, and as we will discuss later, we will have a separate structure, and this separate structure is going to have the participation percentages for these exams, and we are not going to hold this inside our structure, and this will be another structure totally different. And I want to store them both, but I cannot use it since I have just one location. So with this memory manager, I'm actually virtually multiplying these memory locations. So instead of one location, I'm virtually having 256 locations. So if I need to use multiple different structures, then I can store them, even though it is actually a one structure. This memory manager is virtually going to split them so we can have this functionality. So to define this memory manager, you can call it whatever you want, but I just like to call it memory manager because it's just easy to understand. And as we talked before, we will say RefCell here. And as we discussed, inside this RefCell, we actually want to put our data inside this RefCell so that we can manipulate it much easier than the traditional Rust rules. And the data inside will be memory manager, and this memory manager will default memory implementation. And we are going to say this is the type of the data actually that is going to return to us. And we are going to define the data here. This will be a RefCell, new one, and we are going to say memory manager in it. So we are initializing memory manager here, and whatever we will have here, we are going to hold it with RefCell. That's why we said the type of this memory manager will be RefCell, and it will hold the memory manager type here with the default memory implementation. And inside this init, we will say default memory implementation again, and we are going to call the default function. This should be a lowercase. I know that it looks complicated, but again, since we are going to do this a couple of times, we are going to get used to it because it has a couple of parts that actually make sense. So we know that we are going to hold the data in a RefCell, so we create a new RefCell with this new function. And inside this new function, what we want to do is we want to initialize a memory manager. So we are going to use this init function from the memory manager, and this function gets a parameter, and for the parameter we are going to give the default memory implementation with the default functionality. Okay, so this will be our memory manager, and as we will see in a couple of minutes that it's going to create us two different locations. First one will be an exam map. So this exam map will have the exams that we will have in our smart contract. So let's say the first exam is CS101, the curve is 65 and it's out of 100. And the second exam is CS102 and the curve is 55 and it's out of actually 75. So we will have different kind of exams, and we are going to hold this list of exams with this exam map. Its type will be a RefCell again, but this time it will be a Stable BTreeMap. So Stable BTreeMap is actually a special structure for us. So we are using BTreeMap here. So BTreeMap is like the dictionary in Python. On the left side we have an identifier and we can call it as the key, and on the right side we have the value. So instead of having an array or a vector and we just have their indexes and we don't write their indexes, we just know it from our vector and we just have the values. But this time we will have a key and value. So instead of indexes, we are going to name the keys and name the values. But of course we can name the keys as the indexes that we were doing with the vectors. Inside this Stable BTreeMap, we will say U64, and this will be the type of the key. So I want to give IDs to this exam like 0, 1, 2, 3, 4. For that reason, I'm using U64. Next, I will have an exam, and that will be the value. So it will be like the first one is this exam, second one is this exam, so that we will have the ID exam collaboration. And finally, we are going to pass the memory here, which we defined in our previous lesson. And this will be the type that will be returning to us. But actually to assign this, we are going to say RefCell new. This is like the one that we created here. But this time what we want to actually initialize is Stable BTreeMap. Here we wanted to initialize memory manager so that we set memory manager init in a RefCell new function. So in this time actually we are doing the same thing. In a RefCell new function, we are going to have a Stable BTreeMap, and from this we are going to call the init function like we did the last time. But this time we are going to be more complex. So we will say memory manager, and this is the memory manager that we defined here, because as we said that we actually have one location, but we want to virtually split these locations and we want to put our data in different locations. For that, to define this, I will use memory manager dot with, and this means that we are going to do this under this manager. This memory manager dot with takes a closure, and this m will be the value that we'll be using. And we are going to borrow this m, and we are going to say get memory ID new 0. Again, I know it looks too much, but just wait for the second one and we will see that the second one will be much easier. So let's just see that what we did. Actually, as we can see, the idea is very simple and repetitive. We defined our memory manager with a RefCell new memory manager in it. We are defining our BStable3 by saying RefCell new BStable3, and we are initializing this under the first location of the memory manager. For that, we are using memory manager and we are borrowing and getting the memory ID with the 0 so that we will have the first one. Now to show you how similar actually our second one will be, I'm going to copy and paste this, and instead of exam map, I will say participation percentage map. Alright, and it will be a Stable BTreeMap, and we are going to use U64 for our keys, but this time we are going to have U64s because we are going to say for the first exam, if we have the value 65 for the key 1, it means that for the first exam we have the 65 as the percentage, so it will be 65% participation. And we corrected that too. We are initializing a new Stable BTreeMap and we are using memory manager, and as you can see we are doing the same thing, but this time instead of 0 we are going to say 1. And let's put semicolons here. and we don't have any errors. So actually that will be the hardest part of our smart contract. So congratulations to making this far, and it's going to be much easier after this point. But let's just see what we did. So first we created our struct, and we said that we want to serialize and deserialize this struct between our upgrades to the state. And for that reason, we had two different traits. And after we had the necessary structure, we had our thread local. And in this thread local, we said that we are going to define thread specific variables, but since ICP is single threaded, we will have no problem. And we said that in this context, we can just have one location, but we want to be able to save multiple structures to the blockchain. For that reason, we are virtually splitting this, and we are doing this with the memory manager. And for the first location, we defined an exam map, and we used RefCell to actually overwrite the borrow checker of the Rust. And we defined another one, the participation percentage map. We didn't have any different structures for this, so we just defined this structure inside the thread local. But since we had a custom structure for what we are going to hold in our exam map, we had to do this whole process, but it's going to be much easier after we got used to it. So that will be all for this video. Thank you very much. And in our next video, we are going to define our functions for this smart contract. We are going to have query functions and update functions. Thank you very much, and I will see you on the next one.